Okay. Solving radicals number 2. There are only 9 problems, but these problems are kind of complicated. So, whenever you have a square root equals something, your solution method involves squaring. So, in the past we had something like this. Let's make it easier. Can this have a solution? Yes, if x is greater than or equal to 0. Okay, and then depending on the situation, you might just have to plug the number back into x and see if the square root equals a negative number. Okay, and the solution method is just square both sides. We get x plus 6 equals x squared. So that should make you think quadratic. So we subtract x and subtract 6. That gives me x minus 3 and x plus 2. So x is 3 and negative 2. Are those okay? The negative 2 doesn't work. Now, does it not work because the 2 is negative? No, it doesn't work because when you plug it back in here, we get a square root equals a negative number. So if it said x plus 4, would negative 2 be okay? Yeah, negative 2 would be just fine. What if it said x minus 6? Then neither of those work. Because when you plug in 3, 3 minus 6 is a negative, and square root cannot equal a negative. So the idea today is exactly the same, but the process is going to take us a lot more time. It's a little bit more not a little bit, it's quite complicated. All right, let's dig into one of these. So this is actually just like what you've dealt with. So we square both sides. The left side is going to be 9u squared. The right side is 10u squared minus 3u plus 2. Subtract 9u squared. And I get u squared minus 3u plus 2, which would be u plus 2 and u plus 1. So I get u equals negative 2 and negative 1. And then I look back at the original. Do those work? No. Oh, I did it backwards. Okay. Do 2 and 1 work? Yes. They're both fine. Why is that landing over there these days? Okay. This is where it gets a little bit harder. We have 2 square roots, which we did last time, but it was just square root equals square root. Now I have square root equals square root plus a non-square root. And because of this, we're going to have to square twice to get rid of each of the square roots, and you do one at a time. So, a lot of times you'll see this. The square root of y plus 51 minus the square root of y equals 3. You don't want to square with both roots on the same side of the equation. You can do it that way. It will work. It's just going to make things even harder than they need to be. So if this is your setup, move one of them to the other side before you square. Luckily on this problem, they're already separated. So the left side is easy. I just get y plus 51. But the right side is tricky. It's a binomial. It's y, the square root of y plus 3 times the square root of y plus 3. You should be able to do these in your head. It's this times itself, which is y. And then it ends with this times itself, which is 9. What happens in the middle? It's this times 2. So the square root of y times 3, which is 3 square roots of y, times 2, is plus 6 root y. Does anybody not understand that? Okay, let's write it out. So root y plus 3, root y plus 3. That is y. That is 3 root y. That is also 3 root y. And that is 9. Combining like terms, I get y plus 6 root y plus 9. What's that? So if I had 1 plus 3 squared, is that the same as 1 squared plus 3 squared? No, because 1 plus 3 is 4, and 4 squared is 16, and that does not equal 16. So, great question. So our postulates are those. So when we built our number system and when we built algebra, we agreed on postulates, which you guys don't even know what those are. Kegley does. And those are our postulates. Why did we do it that way? Because if you are counting M&Ms, that's how it works. Right? So, yeah, you agreed to it when you started counting on your fingers. Yeah. Cuz that's how it works. When you're physically counting something, that's how it works. So, Kegley, if we built a square that was 1 plus 3 and 1 plus 3, right, you end up with 16 squares instead of, what would that be, 10. Don't worry about it. Kegley gets it. Okay. Yeah. No, you weren't. Okay, now what? Well, I've got an equation that's a big mess, and inside that big mess is a square root. So I need to isolate that square root and then square again. So I need to decide what's the best place to put everything. Oh, this one ends up being pretty easy, because when I subtract y, the y's cancel. So I'll subtract 9, and I get 42 equals 6y, 6 square root of y. Should I divide by 6? Yes, only because 42 is divisible by 6. If this was, say, 47, I wouldn't divide, because then you're going to get a fraction, and you have to square a fraction. So I would not do it that way unless it works. So 7 equals root y. Hopefully we'll run into one of those in a second. Now what? Square both sides. And I get y equals 49. Is that okay? I don't know. We got to look back here. Does 49 work? Do I actually have to check to see if the two sides are equal? No. Although that's not a bad idea. Anytime you're taking a test with algebra, I recommend you always plug your answer back in. But we're just checking to see if a square root is equal to a negative number, and 49 does not create any problems. Yes? Hopefully we'll see one. All right. Okay, this I think will answer that question. So, I need to change this. What is it about this I want to change? I need to get one root by itself. Now, technically it will work if I square it, but it's going to be a terrible mess. So, which one do you want to move? I like moving the negative one if there is one. So, square root of 6x plus 34 is equal to the square root of 2x plus 10 plus 2. So now I square both sides. The left side is easy, 6x plus 34. The right side is a little bit harder. What is that times itself? 2x plus 10. And what is this times itself? 4. And what happens in the middle? 2 copies of that. So 2 square root of 2x plus 10 plus itself gives you 4 roots of 2x plus 10. Does anybody want to see that multiplied out the long way? Yeah? I heard a yes. Okay, that is 2x plus 10, piece of cake. That is 4. So the hard one is doing this, which is 2 times the square root of 2x plus 10. And this one is exactly the same thing, 2 times the square root of 2x plus 10. And if you have 2 of something plus 2 of something, you end up with 4 of that something. It's like 2x plus 2x is 4x. Okay. Now what? Let's move everything except the square root to the left. So we will subtract 2x, and I get 4x. And over here I have a total of 14. So I'm going to subtract 14. Can I divide by 4? Yes. In this case I can, and I'll show you what you do if you don't want to. So divide by 4. On the left side I get x plus 5. On the right side I get the square root of 2x plus 10. Now what? Square both sides. So what is that? X squared plus 2 copies of 5x, which would be 10x plus 25. And then the left side, the square root and the squared cancel, and I just get 2x plus 10. Now what? Subtract 2x and subtract 10. X squared plus 8x plus 15. So that factors into x plus 5 and x plus 3. So my answers are -5 and -3. Do those work? Yes. I get a 0 on one of them, but that's okay. So -5 does not create any square roots that equal negative numbers, and -3 does not either. Okay. Now, what if I can't divide? So let's say I get to this step and I have a 6 right there. Can I divide by 6? Yes, but I would create fractions. And squaring fractions and dealing with fractions is actually more difficult than we need to worry about. So is there something I can divide by? 2. And notice, I'm not paying any attention to that stuff. That is not really a 2 or a 10 inside there. It's the square root of 2x plus 10. So it doesn't really have any factors in there that I can mess with. So I'm going to divide by 2. And I get 2x plus 10 equals 3 times the square root of 2x plus 10. Now I'm not sure if this is going to happen because this is the first time I've ever done this assignment. I need to square. So squaring the left side is pretty simple. 4x squared plus 2 copies of that, which would be 40, and then 100. But what would the other side be? Well, do I have to do this same multiplication on the other side? No, because it's not a binomial. There's really only one thing happening there because it's multiplication. So in this case, I can distribute the squared because there's no addition or subtraction there. Right? It's the difference between 2 plus 4 squared and 2 times 4 squared. In this case, I cannot distribute the 2. I have to do 2 plus 4 and 2 plus 4. But in this case, I can rewrite 2 squared 4 squared. So it ends up being 9, and then that just turns into 2x plus 10. And then I'd multiply the 9 in and solve. It probably won't solve because I made this up. All right. Okay, looks like those are the only types of problems. You do 3 of each. Do you want to see another one? Okay. You're not good. Okay, good luck.